Hi, I'm Bill Patterson. I'm professor and director of the Saskatchewan Isotope Laboratory here in Saskatchewan, Canada, the land of living skies. I'm here today to talk to you about a project that we hope to complete this summer. This project involves determining stable isotope values of groundwater. This would be lake water, stream water, river water, anything that we can collect that's going to represent the meteorology of the past year. We can look at where the water came from, we can look at how it's moving across the continent, and we can use this information to better understand how the atmosphere works. By gaining a better understanding of how the atmosphere works, we can better prepare for future changes that may be related to climate change, for instance. We may see a series of events in the future that are predictable. And by predicting the weather in advance, we gain a substantial advantage. We can maybe tell farmers it's a good idea to plant a more drought-resistant crop this year, or it's a good idea to plant a crop that can handle large amounts of moisture if we think it's going to be a particularly wet year.
Water is one of our most precious commodities, yet it is surprisingly rare. Rising temperatures are going to change the way in which that water is distributed on the Earth's surface. NOAA has announced recently that the temperature of the last 12 months is 2.8 degrees Fahrenheit higher than the previous 100-year average. The devastating weather of the past year is an example of such changes. Tornadoes in the Midwest and South caused by warm, wet air colliding with dry, less dense air are a violent example of weather events that are becoming more common. The flooding of the northern Great Plains and southern Canadian prairies caused by excessive snowfall in the Rockies is another example of what we can expect in a warmer future.
Much like a black box, the flight data recorder for an airplane, the isotope values of river and lake water record events in the past. And they preserve this record not only of how the water evolved as it moved across the continent, but where it came from ultimately. We can look at the values of oxygen and deuterium to determine the history of this water. And the more we know about the history of the water, the more we can say about how the atmosphere behaves, how the world itself behaves. Inherent or entrained in the atmosphere are what are called atmospheric rivers. And these behave a lot like rivers like the South Saskatchewan River behind me here, in that they move large amounts of water. In fact, the largest atmospheric rivers can move 10 to 20 times the amount of water that flows out of the mouth of the Mississippi River. This is at any given time. There are numbers of atmospheric rivers in the atmosphere functioning from season to season, from year to year. Some of the more famous include the Pineapple Express that funnels water from the Central Pacific Ocean to the coast of California, Washington, Oregon, and British Columbia. Now this Pineapple Express can produce much needed rain for agriculture in the Great Valley of California, but it can also lead to excessive flooding. And we've all seen images of that flooding on the news. Devastating floods that can destroy towns, cities, personal property.
You're probably wondering how we decide where to take samples. We use all of the information that we can gather on precipitation, temperature, atmospheric pressure, humidity, wind speed, and more. So far, we've processed several billion weather data to generate the videos that you're watching here. The raw data from these videos was provided to us from Environment Canada, the United States Historical Climatology Network, and the Alaska Climate Research Center. We're looking for places that display the most variability and/or the most important locations for agriculture and population centers that rely on precipitation, or alternatively, places that are endangered by this precipitation, whether it be the form of rain or snow. Our plan is to break this transcontinental sampling trip into 4 legs to run continuously, from Saskatoon to Pennsylvania, from Pennsylvania to California, loop through the Rockies so that we get moisture coming from both sides of the Rockies, and then north to Cluff Lake, Saskatchewan.
Isotope values of precipitation are much like a flight data recorder for an airplane. We don't need to recover the entire plane to determine what's happened. And in this case, we don't need to recover all of the moisture. We just need that black box, that isotope value that tells us the history of that water as it moves across the continent, as it comes from an ocean or evaporates from a lake surface, entrains itself in the atmosphere with other moisture, and then falls as precipitation. This whole story is recorded in the isotope values of this precipitation. And by looking at these fingerprints of individual lakes and rivers, we can piece together a story that's the history of the water vapor in the atmosphere. This is fundamentally important for understanding how the atmosphere works today. And it's important that we take a good look at this on a year-to-year basis. It's not a one-off event. We're not going to gain a complete understanding of how the world works from one sampling season, but we will gain a better understanding of how that one sampling season behaved.
Why use motorcycles to take water samples? Motorcycles give us a better feel for the climate of each region we travel through, though this may not always be a good feeling, to be sure. The impression that I'm left with from this experience is helpful in interpreting the data once the analyses are complete. You can't gain that experience in an air-conditioned or heated car. Additionally, enduro motorcycles provide the ability to reach places that I could not get to using a four-wheel drive vehicle. When traveling by bike, people often are more comfortable coming up to ask what it is we're doing. Contributors will be able to follow along on the blog that will be updated when I have access to Wi-Fi. I'll try to provide video and photos whenever possible. I usually explain my research to 10 or 15 people a day. This is often at gas stations, restaurants, or just anywhere we stop. This allows us to share our research and our findings with a greater number of people, be they public sector, government workers, or just interested bystanders. I'm requesting funding to cover the cost of analyzing approximately 300 water samples. I'll volunteer my time, pay for my travel costs, and use my personal vehicle to conduct this research if you can help with the cost of analyses. To keep costs down, we've been known to sleep in storage sheds at campgrounds, remote rural cabins, and camp in the deserts and mountains. PetriDish funding is critical to the characterization of the exceptional weather of the past year. Normally, a funding cycle requires about a year from the time an idea is hatched before the research is actually funded. Therefore, in order to fund this research in a traditional funding program, and if the funding was available, we would have to wait until the fall of 2013 to start sampling. That is clearly too late, as all the isotopic evidence will have literally washed away. It is really important that we do this as soon as possible if we want to better understand our past year of weather.
Thank you for your time and interest in this short video presentation today. I hope that you'll be able to support this work. It's very important for gaining a better understanding of how the atmosphere works, very important for gaining a better understanding of how the world works, and we all benefit from understanding what's going on around us. I hope you'll be able to help support us and come along for the adventure, because it's sure to be a crazy one. Thanks again for your time.